Now in this video, I'll be just solving more problems in molarity, and next example that I can see right now here is 13.10 on page 5. Oops, let me just 583. And so this is what's given here. They say, well, calculate the amount of the solute present in a given amount of solution using molarity as a conversion factor. And you guys notice already probably that molarity can be used as a conversion factor. So let me state what's given here. And what's given here is you got the molarity of the citric acid. M of citric acid is 0.400, this big M. And then volume here, 125 ml. And what they want me to find is the grams. So mass of the citric acid is question mark. All right, so how do you do it? Well, we can also apply the two previous formulas that I already used in my previous video, but they're very specific here. They want to use the molarity as a conversion factor. So how do we do this? Well, you have to, guys, understand that when you have this big M, 0.400, you can always break it into the two units, mole of citric acid over the 1 liter of solution. So anytime you're given molarity, it's always whatever this number is, moles, and in the bottom is going to be always 1 liter. Again, if you're trying to now unpack this molarity unit, it stands for, it's broken into the moles over volume over liters. So when you have a number, molarity number, you can always express it as this number will be number of moles of solute divided by, always when you use this big breaking into these units here in the moles and the volume, always going to be 1 in here, 1 liter of the solution. Okay, and this is nothing else as a conversion factor because you got two units, one in the numerator and the other one in denominator. So that could be used as a conversion factor here. So before you can use the conversion factor, though, you have to set it up the right way. The problem here is that you got milliliters and you got liters here. So how do we deal with this problem? Well, you always state what's given. And in this case, well, two of these, of course, are given. But this one, we already talked about the conversion factor here. This one is not. It only has 1 unit here. So we first want to convert this into the liters. So 1 liter is 1,000 milliliters. Cancel, cancel. So now you can use this as a conversion factor right here. So you can say now that 1 liter of solution is equivalent to 0.400 moles of this citric acid. And now the same thing, you can just put this, cancels out. So now you got the moles of citric acid. How do you get the grams? Well, you can convert. You can say 1 mole of citric acid. And again, in order for you guys to know figured out the molarity of the citric acid, you really should be supplied with the molecular formula. And there it is. They gave me as C6H8O7. And you already know how to calculate the molar mass. I'm not going to spend my time here doing it. But just to be really quick, 6 times 12.01, 8 times 1.008, 7 times 16. Once you get those answers, those numbers, you just add them up. That will be your molar mass. And so my molar mass here is 192.14 grams of citric acid. And so when I do this conversion, first of all, I need to cancel the units I don't want. And so when I'm doing now these conversions, all I have to just multiply, divide everything here that's in the proper order. So it's going to be 125 divided by 1,000 times 0.4 and then times 192.14. Now, significant figures, 3, 3, 5. So, of course, I'll go by the smallest number of significant figures, 9.61 grams of citric acid will be my final answer. And that's how you use the molarity as a conversion factor.